Hey, Pratik, are you there?
Yes. Hey, James.
All right. How's your day going for you?
I'm pretty good. How are you?
Good. Oh, it's going pretty good. Are you surviving the winter blast that just whipped through the country?
Yeah, actually. We almost had a day off, but so close we didn't. That's too
How
bad.
cold did it get up there?
I think we hit 20 or something last night.
Okay. Yeah, I think we hit about 6 last night. And,
Damn. Oh yeah, you guys are way.
and we get hit pretty hard, and it happens sometimes when we have a bunch of snow. And you know, we're not really well equipped to handle all the snow, so we definitely had a snow day. And it's fine with me. I'm still working. It's fine. Not a big deal. I can do stuff online, but students don't probably like that too well, but hey, it's good for them. Uh, Kids are loving it. Have 2 days, have snow days, Monday and Tuesday. Well, we'll see if they go back to school tomorrow though. But
No,
I
wait,
tell you,
I thought Monday was MLK Day for.
it was. We also had a big snow on it, so I guess it's kind of both. Um,
Oh, okay.
but I remember living up north and it was like -30 a lot, -40, and that was
Jesus.
way too cold for me. And I said, "Oh, I'm done with that."
I don't,
But
wow, I've never been in a place that's where it's that cold before, I'm not gonna lie.
oh yeah, yeah, I was living out in Wisconsin, and
Wow.
polar vortex just swept through one year when I was up there, and that was the year I decided that's it for me. When I lived in
Fair.
Washington, it was like -12. I can handle -12, but -30, I was like, that's too cold.
Yeah, that's fair.
Okay, well, tell me a little about the class. How's it coming along? You took your quiz. How'd you do on it?
I did well. I got a good score.
Hey, hey, great job.
Thank you.
Did you get an A on it?
Yes, I did. I got a 97.
Awesome.
All right. Yeah. So, um, my grade did hit B. It hit 85. So that's good.
Okay.
Um, I'm trying to think. Okay, we had a grade go in today, and we had something called a workshop, which is basically where she gives us like a shorter number of problems, and
Mhm.
it's a group assessment basically, where you have like a couple of people in your group work together to solve the problems.
Okay.
But they're meant to be harder, right? They're harder than like generic like quiz problems or test problems. So, but the point value is usually less too. Like this one was 16. There's usually when 16 to 21-ish points, some of that,
Okay.
right? So, I mean, I tried to memorize the problems. I'm not sure if I did too well doing that, but can you help me? I think we're gonna start there, where we're gonna um go over the problems from that today, because I don't expect there to be anything of this difficulty on the test, but I feel like knowing it will help. So,
Oh yeah, most certainly. Okay, let's jump here to the bit paper. And are you still on the iPad tablet?
yeah, yeah,
Okay.
yes.
Let me see if I can share my screen with you. Can you see everything okay?
Yeah.
Okay, so tell me what's going on with these problems.
So I didn't really have. I mean, I just kind of was confused because I mean, I tried to have my friends walk me through it while we were doing it, but it was still kind of confusing. So
So is the first one saying find the region to which this inequality is true?
yes, so it's supposed to be like an interval notation type situation.
Okay.
Yeah.
Well, tell me a little bit what's going on here with the square root. How can you recalibrate it? The
You
supports
can
clearly.
put it this way,
Okay.
and then you can have it um like this.
Okay. And let's say if we were to power it up to the 12th power. Why do we want to power up to the 12th power?
Common denominator.
Right. 4 and 3 would go into it.
Yeah.
So if you pretty much if you have this, that means you have this, which corresponds to this.
Yes.
Now, let me ask you a question. If I looked at a half, and if I was to square it, I would get a fourth.
Yes.
Which one's bigger, a half or a quarter?
A half.
Half's bigger
Yes.
because the denominator is smaller, right?
Yes.
So if I looked at x and x squared, which one would be bigger then if x is a half?
If I looked at x and x squared, which would be bigger? 1/2 and 1/4. X.
X be bigger.
Yeah.
But let's say if x was equal to 2, which one's bigger, x or a half? Or is x to the squared?
The x squared.
Right. So here's what happens. When you cross the threshold of 1, things start taking a little bit different turn. So
Okay.
you're going to have x is going to be less than or equal to x squared, which is less than or equal to x cubed, and so on and so forth. You just have the powers increment from there. And you can have things like 3.1 if you want. There's no reason why you have to have an integer value. But this is only going to be the case if x exceeds 1 or equals 1. When you're between 0 and 1, it takes a different turn.
Okay.
This is where the inequality is going to flip. Looks like that. So if you want the case, we're looking at the x to the 4th, x to the 3rd, if x exceeds the value of 1 or equals 1, 4th is more powerful. If it's within this region, then it goes in the other direction. Okay, can you say it all, Clay?
Yes, I can. No.
Okay, so take everything and you go to the 1/12th power. Up top, you'd have this.
Yeah.
And down below, take to the power again, you would have this. So it really depends on which region you're on. And that threshold is right there at that 1. It's kind of a fine line.
See. So how would we put this in interval notation?
Well, an interval notation for the one on top, since you can include it, you put a bracket and then go off towards positive infinity.
Okay.
Now, the one right here, if x is going to be greater than or equal to, there's that greater than or equal to that refers to your bracket. And the strict inequality refers to your parentheses. And just drop in your 1. So it's a real fast transliteration. I mean, look at your interval inequalities, or look at your equalities, or even like a number line.
Gotcha.
Good.
All right. Okay, makes sense.
Perfect. I'll let you scroll down to the other problem you're looking at.
Yeah, okay. Find the inverse of f of x equals x squared minus 4x plus 3, where the domain restriction is x is less than or equal to 3.
Okay. Now, let me pull a problem over here. And can you see if I put it in the left-hand corner? Or do you need to zoom out in your browser?
I see it.
Okay. I'm gonna move it up a little bit more so there's a little more writing space. If I put it there, can you still see it?
Yeah.
Okay. So tell me what the inverse is.
It's where it's when you flip it over y equals x and it still remains a function.
Okay. So you take the graph, you flip about y equals x, you get the graph of it. What happens when you do function compositions with it?
Function compositions.
If you plugged in the inverse into the function, you get a
X.
x out of it. So you either do the left inverse kind of idea, this right, it doesn't really matter. In your cases, they're the same, but anyways. Now, tell me, if I gave you this one, y equals 2x plus 3, could you find the inverse for that one?
Yes.
Okay, why can you find the inverse for this one, but not so much this one? In other words, why is it hard?
Because that one's a quadratic equation, whereas this is just linear equation.
Okay, fair enough. Because for the one I can very quickly solve for if I needed to,
Yeah.
not much of an issue. So to solve or get the inverse, it's really a matter of solving for x. Now, a lot of times we tell students is you take the y's, you flip it into x's because they're so accustomed to solving for, for the y. That's fine.
Mm-hmm.
Now, there are really two different approaches that I could do here. And let me just show you one approach first off. So I'll say y equals, and I'll have x squared minus 4x plus 3. Now, suppose for a second, if I was to debug the code, and suppose that 4x wasn't there, could you solve it?
I mean, I'd flip the X and the Y first.
Okay, but could you solve for x, or solve and get the inverse if this was the function you're really looking at?
I think so. I think so.
Absolutely, right?
Yeah.
You take that 3, move to the other side, and take the square root, and you have to consider if you want positive or negative. Bang, you're done, right? Not a problem. Okay, now what we're doing again is we're trying to develop the insight, the intuition, so that we can really master this real well. Suppose if I striked out the x squared, could I
Yeah.
solve it? Sure, it's
Yeah.
linear. So the problem is it's not necessarily I have an x and an x squared. The problem is that they in the same equation. They're working in tandem.
Yeah.
So when you see that kind of issue, what you should start considering is, what if I complete the square? Now, to complete the square for quadratics, if it looked like x squared plus bx plus c, here's how it works. Now, what they're going to do in class is they're going to teach you a really long, convoluted, complicated way. They're going to take like 30 minutes to go through it. Here's the secret to it real fast. Here's what you're going to do. You're going to take whatever's in front of the x. I don't care if it's a 4. I don't care if it's a 5. Take whatever's in front of the x, half it. Put a little square on top. Then what you're going to do next is you're going to have to subtract off v over 2 quantity squared. Trick right there, right there. That is the whole entire completing the square process, and this works for any problem where you need to complete the square. Whether it's an equation or an expression, this will do it right here.
I see.
It's a one-liner. So if you have this identity in hand, man, look how fast you can go through this now. Subtract off 2 squared, or really negative 2 squared. Take the negative with it, but squaring it. You would have x minus 2 squared, 3 minus 4. There it is. Now, suppose if I switch it up now, x's and y's. Bring the 1 to the other side. Square root it. And whenever you square root, you do have to consider the positive or in the negative case. It's a package deal, they go together.
Mm-hmm.
Most students will make a mistake and just say positive, but you do have to consider both of them and bring it to the other side. And then from here, you go back to the restriction and you say, okay, what am I really, really looking at? Right here with my graph, x, I see I have a parabola. I'm looking on the left-hand side of 3. So the parabola is going to open up. So it's going to look something like this eventually. Notice how
Yeah.
I'm not really pinpointing it down. I'm just kind of using some inference to give me an idea as to which direction I need to go. So it's over here. It's gonna look something like this. And if I was to reflect it above my axes, it would look a little bit like that. So it seems to suggest then that I'm probably talking about the positive case. Let's just double check that. Oh, actually, maybe the negative case. Okay, see if that makes sense to you. There's a lot going on.
Okay. So let me make sense of this. So you have, okay. So you have the b, and you square it and add it
Mhm.
to both sides, or just the one? Okay, hold on. X squared plus b plus c equals x plus half of b squared minus b half of b squared. Why would plus c? So I feel like what I was taught is similar, but I'm just getting like confused trying to correlate the two. So maybe if I show you what I was taught.
Yeah, let's see what you got.
So what I was taught is, like, let's say if it was x squared. Okay, let's just take x squared plus minus 4x plus 3, right? I would have been taught equals equals what? 0? No. Wait, so how would you take the inverse of a function? Wait, one sec. Okay. Right. So yeah, so equals y.
Mhm.
Then there was a so they would have told me to do x squared minus 4x plus 4 equals. So then or in a step before that, which I didn't write, you would have subtracted so y minus 3,
Mhm.
right? And then plus 4. So then you become y minus 1. And then I think what you're saying is you would do x minus 2 squared, because that's what like the factored form of it is.
Mhm. Mhm.
And then you would have y minus 1, but then you'd root both sides, and you would have plus or minus because you're even rooting it. And then you would add so 2 plus or minus y minus 1.
Mhm.
But then you would flip it. So
Yep.
that, I feel like that's what I was taught.
Yeah, honestly, a lot of people are taught this, and there's reasons why students are taught this. This is okay. Um, there's nothing wrong with it, but here is the kind of issue I do have with this approach. This approach only works when you have equations, because what they say is add something to the other side that you would add to this side, so you can get this whole entire thing. You have to think of some way to compress it down to a square. So they really make you think really complicated, really hard about how am I going to go from this step to this step. And that's the step that a lot of students start struggling and stumbling over of how to go from here to here. Then once I have it on the other side, they say, okay, I can go ahead and compress it down, and they start getting it. Then once they get back to this stage here, they're usually okay. Here's kind of the issue. Once again, you can only do this if it's an equation, not for an expression. Suppose if I just asked you to put this quadratic into vertex form, how would you put this in vertex form as f of x, and it's not a y? You can't really add something to the other side.
So can I try it?
Go right ahead.
Minus, because you're tech, like, okay.
Do you see how you're kind of stalling out a little bit though?
Yeah.
Okay. And this stalling right here that students do experience when they're working with completing the square, we can overcome that a whole lot faster if you follow this protocol right here. It's still completing the square process. It's a little bit of a different slant to it, but it's the same idea, just repackaged a little differently. So try the way I'm showing up here real fast and see how fast you get it.
So x squared, so x squared plus 4x plus 5 equals x plus 2 squared. What you're saying, x plus 2 squared minus 4.
That's right. And don't forget about the
Wouldn't
C.
plus 5
That's it.
equals x plus 2 squared minus 4 plus 5 plus 1.
You're done. That's completing the square.
I see.
Square has been completed. Now, look back up here. See, do you still want you to kind of figure something out right here? You got to ask yourself, okay, how am I going to complete this square to get into this form? You're going to have to think about that for a little while. There's less thought up here in this process. If you remember, it's take half a linear term each and every single time.
Mm-hmm.
And that will substantially speed up the time it takes on exams. Okay, hold that. It's your little secret, lock and key, your eyes only. I'll have the secret safely guarded within you now.
I see. So it's that's x plus b half squared minus b half squared. But the thing is, over here when we did the problem, we said x plus half squared minus b half squared, which ended up being 4, right?
Mhm.
Is that always gonna be b in general?
That's always been the case. Let me show you why. So whenever we're completing the square, we're really looking at the binomial expansion. And let me say a plus b. So we don't get too confused, I guess.
Yes.
Now remember when you expand out, you'll have a squared plus b squared, but what happens right here in the middle?
2ab.
2ab. So if I take this and I say x, and let me say d now, make it a little slight difference. X squared plus d squared 2 dx. Well, if I want to get back to that, let's say 7 now. If I want to get back to that 4, that's why I'm going to half it. I half it because I'm about to multiply it by 2. So if I take it, if I say x plus, I half the linear term, I will get x squared. And because I halved it, 2's divide out, back to the b. And that'll get me back to my 4. And I do have this plus 4. Now, the problem is when I look at my quadratic, do you see how things are lining nicely right here and right here?
Mm-hmm.
But what's the difference? It's at plus 4, isn't it?
Yeah.
So what if I skew this over here to the left and I subtracted a 4 from both sides? Then I can substitute out, in other words, the x squared plus 4x right there. And that's why that formula works. That's why you always want to take the middle term and half it. Because
so that's why it's x plus b squared minus b squared, b half squared, b half squared plus c.
because I'm going to apply the binomial theorem here. I multiply it by 2 because I halved it, so 2's are going to divide out. And this piece is going to be b over 2 squared, but you're subtracting it off. So it's going to go away anyways. And there it is.
I see. Gotcha. So if we take this back to my problem. So you have f of x equals x squared minus 4x plus 3. This equals to x minus b over 2. So x minus 4 over 2, which is 2, x minus 2 squared, plus 6 b 2 over b over 2 squared, so 4.
Make
I
sure
know,
you
is it
subtract off
minus or
4.
Is it minus or 4? Minus or
Closing
plus?
and minus it.
Okay, yeah. Minus 4 plus 3.
That's it.
Yeah, gotcha.
Okay. Let me throw a few problems up here if you're real fast. And I want to see how fast you're going to do it now. On your mark, get set, go. Just double check that. It's not 8. Remember, it's squared.
Minus
So 4
b
squared
over
is
2, b over 2, which is 4. It says b over 2.
That's going to be over 2 squared.
So 4 square, so 16.
16.
Yeah. And the x minus b over 2, which is 6 over, so x, okay, x minus 3 squared minus 9 plus 5. 4.
Well, let's see. That took you about maybe a minute to 2 minutes. Pretty fast, huh? Okay, slight adjustment here. Okay, so what if I had a 2 in the front instead of a 1? Okay, so in these situations, what I'm teaching you works exactly the same way. Slight modification though. Here's what you want to do. Factor out the 2. Don't worry about the 7, just worry about the x squared and the x again, because that's the problem that we identified. So factor it out. Just like this. Then do exactly what I just showed you on the inside here. So complete the square. You would have x half of 2 subtract it off. And then from here, it's a cleanup job. Okay, so you get 1, -2 after you distribute. Add it to 5, or add it to 7, get 5. So this is going to work beautifully if there's a 1 in front, and if there's not, it's okay. It's just a slight modification you're going to need to do. Okay, so let me give you 1 right here. Okay, let me time you how fast you can go on it.
So I would wait, can I go back to the other problem real quick?
Sure, if you need to.
Okay.
Good.
2.5 squared is 2.5 times 2.5.
Now,
No, wait, that was 6.25.
Yeah, here's how I would do it. You see how you had to stumble a little bit on the decimals?
Yeah.
Hey, leave it as a fraction. Fractions are great. Just like that. And look what
And then
happens
you
when,
would.
yeah, look what happens when you distribute. You didn't have to worry about that 6.25 anyways, because the 4 is divided out. So that's kind of that thing I've been teaching you about simplify as you go. So sometimes you want to look at your decimals. Sometimes fractions is a little bit better. You just want to kind of see what's going to happen. So you want to look a few steps ahead if you can as you're going through the problem. And the more practice you do, the easier looking ahead's going to be. Perfect. How you feel about being square?
Pretty good.
Good. Okay, so that's one way of how you can approach this problem right here is you could go ahead and complete the square. But another approach is, you know what the end game is of the completing square process?
What?
The quadratic formula.
I see.
So here's the other approach that you can do. Solve for x and apply the quadratic formula. So we'll have x squared minus 4x plus 3, and I'll move that y over to the other side, equals 0. So the
Wait,
quadratic
what?
formula is negative b plus or minus b squared minus 4ac all over 2a.
Why 3 minus y?
I got to get my constants and everything over to the other side, because in order to use quadratic formula, I have to have it as ax squared plus bx plus c equals not 5 or 6. It's got to be 0. So I got to get that y to their side.
Okay.
Now, that would then say that my b is going to be -4. My a is going to be 1. And what's my c value?
3 minus y.
3 minus y.
2.
And then from here, it's also just a cleanup job. I say I can pull the 4 out. When I factor the 4, it becomes a 2. Okay, just may put a few extra steps up here. So I'd have y, and 4 minus 3 is 1 over 2. It all equals x. In the end, Simplify a little further, we'll have 2 plus or minus radical y plus 1. I don't really start getting back to that same thing again, don't I?
I'm a bit confused.
Okay, we take a moment there.
X equals. Okay, so I understood this part. You isolated, you got the other side to equal to 0, so you took the y away. And why does that group into the c term?
The c term is constants. Anything that doesn't have an x in it. Is there any x with a 3 minus y?
No.
So that means it's constant.
Okay, cool. So I understood this whole part where you just plugged it into the formula. But then what I would have done is 16 minus 4 times 3 minus y. I probably would have done 4 times 3 minus y, so like 12 minus 4y. 16 minus 12 minus 4. Hold on. So like I would have done
Plus 4y, yeah. Yep. That would get you the same spot. But it's kind of a difference in philosophy here. My viewpoint is simplify as you go about the problems. Don't expand upon them, then simplify in general. And when you start expanding out, it makes problems a little bit bigger. See how your numbers got a little bit bigger?
Yeah.
Notice how my numbers got a little bit smaller. See how it's easier to navigate with smaller numbers?
Yes.
That's the reason why I'm doing it. Both
So
ways are
what
valid.
exactly?
Both would work.
So what did you? So can you re-explain to me what you did? How you got from this step to this step?
Okay. Let me just rework that again. Okay, so what I notice here is I have 4, and I'm going to factor a 4 out. 4 times 4 is 16. Pop that 4 out. I do have a negative, and I can see there's nothing that negative is going to contribute much to the problem, so it's going to distribute. And I get this. Okay, see if that makes sense to you.
So you, okay.
And then take the square root of 4, which is 2. 4 minus 3 is 1.
So 2 root 4 plus y minus 3. Wait, y minus y plus. Okay, yeah, I see it. Yep.
Good,
Okay.
good.
Okay.
And then next thing is, remember, this equals x. Simplify it down. You have 2 plus or minus square root. And that's just another approach of how I can work this problem. It's a little bit more advanced approach here. If you have, this can be useful for different types of problems later on. So it's kind of good to know what's happening right now with it. But yeah, anyways, that's how you'd find the inverse. You just then make the justification. Do you need the positive case or you need the negative case? You know, what's going to play out?
So if we have x is less than or equal to 3 in right, that's what we have. So how would you
would want the negative case there. Let me explain to you like this so you can kind of see it. Okay, here's my quadratic. And let's say that I'm looking at values which are going to be non-negative. Which part of the graph does that entail?
The right part.
the right part. And if I took the right part and if I reflected it, my graph looks like this. Square root.
Mm-hmm.
Now, let's say if I took something on this side over here, and if I took that graph and if I reflected it, what would that look like? Something like this. So I have to be able to hit these negative values.
Mm.
So when I look at the graph that's been provided or the function that's been provided, I know first off the function is a problem. Now, I know it's going to look something like this, or maybe it's going to be over here like this, without really digging much into it. I know it's going to open up, positive coefficient, something like this. I do know it's saying eventually I'm looking at everything that's negative x, because it's going to be for 3, then 0, then -5, -6. And if I only pick the positive, the principal square root, so if I had 2 plus, is there any chance, any hope of me ever getting negative?
No.
No, there's not. But I
Because
need it
you're
to be
adding
negative
2
actually.
to it, and 2 is already positive.
So that's why I'm picking the negative. That's
Okay.
the line of reason that's going through me without painstakingly spending like 5, 6 minutes really trying to hammer it out. I have the intuition that says, okay, it's got to be on this side eventually. It's got to be negative. I got to get a negative value for my inverse, so I can't be positive. It's got to be the negative.
Mm-hmm.
Okay. Now, see if that makes sense.
It does. So we wouldn't have
Okay.
to provide a domain restriction then.
Well, the domain restrictions on my function call
Yeah, so in
is
our answer, we wouldn't have to provide one.
well, it's kind of inferred, but here you can't have x being less than -1. So it's going to be bigger than equal to -1. And that would actually be captured in the problem too. If you come up here, let's look at it. If you plugged in 3, let's see what happens. You'd have 9 minus 12 plus 3. And let's see. This corresponds to 0. So we're about right there. And what is our other one? That's going to be what? 1. So I think that's going to be a little bit less than it. Should be this side. Your domain restrictions. You have to start this vertex for it to be inverse. Otherwise, it's not going to be. Be where that's going to correspond to.
I see.
Okay.
Okay.
Okay, good. All right, let's look at your third question. Great question. Okay, pull it down here, get out of the way. So what problems were you having here with this one?
So I want to walk you through it and see if I'm doing it right.
Sounds good. Let me see what you got.
Nope. Okay. So I'd start off by squaring both sides, right? So -1 plus 2 root -x plus 5 equals that.
Okay, that'll work.
And then that basically means we just say that
Okay, that would work too.
And then it's kind of where I got. So x minus 1 squared plus 1. So that leaves us with 2 root negative x plus 5 equals x minus 1 squared plus 1. But then I have to divide all this by 2, and that kind of looks ugly. So let's say if it was x squared minus 2x plus 1, and then I added 1 to it, because I took the 1 over.
Mm-hmm.
That would just leave me with plus 2. But I can't divide. So would it be like 1/2 x squared minus x? See how that's so complicated? Like I'm getting lost.
Yeah, let me pause you there. Let's take a look at it. Now, there's a few questions I want you to kind of consider in the back of your mind while I'm doing this. Why am I dividing it by 2, and why am I not expanding out? Okay, just keep that to yourself here for a moment. So whenever I see this problem, it's going to be a nested radical problem, a radical within a radical. And one thing I know about radicals, they're afraid of squares. So if you square it, it goes away.
Mm-hmm.
Now, on the right-hand side, I do have x minus 1 squared, and I got this thing stuck in my mind. Simplify as you go about your problems. In simplifying as you go about your problems means a lot of different things. In the context of polynomials, that means collect like terms. So I'll take that one,
Yeah.
kick it to the other side. Now I have this. Now, there are several things that I could do here at this junction. If I wanted to, maybe I'll go back to completing the square idea. I can do that. But I also do see I do have a square on the left-hand side. I could divide everything over by 2, but as you're experiencing this, that's going to give me a fraction, and I can work with fractions, but sometimes it's easier just to avoid them.
Yeah.
So I could take this and I could square it. When I do it again, I'll have 2, 5 minus x. Now, the thing is that here I have a trinomial. I have to square out a trinomial. Okay, so what I could do at this stage, I can ask myself, well, what does it mean just to square things out? I can go ahead and do a big old long foiling problem. I can say x squared times x squared. And I'll have just this term times this term, and then 2x times x squared. Now, here's how I do it. I don't continue on the same line. You could. But what I'd like to do is drop a line down and start lining things up where it's the same powers. That's going to make this simplification process more manageable here in a moment. I'll do also over the 2. Now, because I did it in that way, simple matter of just adding straight down. X to the 4th minus 4x cubed. I'll have 8 minus 8, 4. And other side, I'll go and distribute now. And then I'll chunk things over to their side. Add 2x both sides. And subtract off 10. There's my polynomial. The objective in these problems is to get the radical equation and turn it into a polynomial equation. Because as soon as you have a polynomial equation, you can factor potentially, apply the zero factor property, do whatever you got to do to make it crank. But let's go back up to the top. I want you to see if that makes sense to you.
It does. So you would square it to get rid of the original radical, and then you would take over the 1 to combine like terms, and then you would square both sides. So you would get 10 minus 2x, and you would get that long oh my bad, the long polynomial thing, expression or equation, and then you would again combine like terms, and then you could, what do you do here?
Which part?
The last part.
The last line there?
Yeah.
Combining like terms and get equals 0 on the other side. So maybe you start using like the zero factor property, or maybe use like the rational roots theorem, the factor potentially.
So how do we find x?
Yeah, this is going to be a little bit complicated here in the end.
I feel like you just listed a couple of ways to do that, but kind of confused about it. Because usually if it's like a 1, 2, this is a 6-term situation. You like, we've been taught up how to do 4 terms. Like we've been taught how to do cube roots, or like, like a cubed minus b cubed, or a cubed plus cubed, or b plus b cubed, or it's like x to the 4th minus x to the squared plus c, something like that.
Do you know anything about the rational roots theorem?
Yeah.
Okay, so if you wanted to see if you can try to factor it using the rational roots, you could potentially use that. The problem here with this one, Pratik, is it's not going to work out too well. The answer that I'm getting here is x equals 2.47568. And probably some more after that.
That's not okay. So is there no way to like isolate x on this one?
Let me think about it from another perspective real fast. And then once you do it algebraically,
Is there any other way to do it?
you can try to do it geometrically.
I mean, she did give us graphing calculators for this assessment, but that was about it.
Oh, okay. So on your graphing calculator, then there is a solve feature on it that you can potentially use. You can also do this geometrically, and let me show you how that would work. So what you would do is on your calculator is you set this equal to the first function, y1, set this equal to another function like y2, and then you just see where they collide. If they collide, the solution. If it doesn't, then it's not. Here's where they would collide. So here's y1, here's y2. And then you would zoom in to see the intersection point. Algebraically, yeah, this is going to be very complicated doing algebraically.
I see. Gotcha. That makes sense. So it would be like approximately 3, 4-ish, or 2, 3. But we wouldn't be able to say. Okay, gotcha. Makes sense.
Okay, good.
I think that's.
Let's go back to your 3 problems again. Let's see if you have any more questions about those 3.
I'm good. So I have a test on Thursday, so I'll get this video like soon, right?
Say it one more time.
So I'll get this video like by what, 6?
Oh yeah, I gotta. Takes a while to upload them, as you know, but yeah, you should still have the same link.
What do you mean?
That link I gave you last time, that should be the same link that's going to take you to all the collections of all the videos.
Oh, okay, cool. All right. So, all right.
Yeah. So just send me a text message later on today if you don't see it later on this evening time. It might be just a little, maybe it's in the cloud or something. I have to maybe push it on my side or something. But yeah, you should have it pretty soon though.
All right, because I plan on like reviewing this, and then so I already redid the quizzes
Mhm.
to practice. I might do some additional online problems. I think I should be good to go. Maybe some classwork problems as well.
Okay. Well, let me know if you get stuck on something.
Of course, yeah.
All right, Pratik. Well, you have a great day then. I'll see you next time.
Yep. Thank you. Bye. Thank you so much.
Bye.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.